Hi, my name is Amir and Kargaran, and today I'm gonna talk about our paper, GlotLID Language Identification for Lower Source Languages. This is a joint work with my collaborators from LMU in Munich, MCML, and Sorbonne University. Language identification, or LID, is the task of identifying the language of a given sentence or document. LID is a well-studied problem, and several LID solutions are proposed for higher resource languages. We believe NLP community should cover as many as languages as possible, not just focusing on higher resource languages. But the NLP for lower resource languages requires high quality datasets, and high quality datasets require high quality LID. Now, what is the requirements of a high quality LID for lower resource languages? The first one is that the LID should cover a broad range of languages. This is because LIDs in general don't have an ability to say they don't know a language. Consider this scenario: we have an LID with support of 200 high resource languages, and we want to give this LID a low resource language, for example, a Baluchi sentence. What will happen? The model will classify this sentence as Farsi, one of the high resource languages that it knows. That's why it's needed the LID to have a broad coverage of languages. The other requirements include LID should be open source to enable collaboration between the researchers, it should be easy to use, and also it should be efficient so it can be used in the cleaning corpora pipeline for lower resource languages, and also it should provide the uncertainty assessment so the users can distinguish where the cases where the highest probability language is certain from those where it's not, and also it should provide the granularity flexibility so the users can choose the level of language hierarchy they want. For example, if they want to classify it as a micro language or as one of the varieties. Our solution to a high quality LID is GlotLID. We choose FastText model as the GlotLID architecture because of its abilities in scalability, open source ease of use, efficient, and providing confidence thresholds. For training GlotLID, we just uses the sources that we deem trustworthy. For example, Wikipedia, religious texts, human translations, and news websites. This gives us a coverage of the 1832, more than any other public LID. As for the evaluation benchmarks, we consider three benchmarks. The first one is Flores 200, the human verified translations for near 200 languages. The second one is UDHR, the most translated copyrighted free document of Universal Declaration of Human Rights. It has more than 500 translations, and the third one is our test part of the data that we gathered. And for the evaluation settings, we introduce set question mark. In this setting, the base set is unknown, meaning that despite the fact how many languages your LID supports, you will always apply your LID on the whole benchmark. This is a realistic evaluation, especially in corpus cleaning efforts when you apply your LID on the whole web. Here you can see the result of applying GlotLID on three benchmarks: GlotLID C, our test part, UDHR, and Flores 200. And here, as you can see, for all of the languages that is supported by GlotLID, we actually get a relatively good F1. We find out for some of the languages we actually don't get any good score, so we did an additional experiment to find out for how many of the languages we actually have a good support. For 1665 of the languages we actually get a good F1, and this is the number of the languages that we claim to be support. As for the UDHR, we apply the GlotLID on the whole UDHR, despite the fact that we don't support some of the languages in the UDHR, and we reported the macro average for the languages that we support after applying on the whole. And this is the same situation for the Flores. Set exclamation mark is another setting when the base set is known. So for example, here you have the benchmark, you have an LID or 2 LID, and you just consider the intersection of the languages that is known to all of the elements that you have. Here you can see the result of comparing GlotLID versus 4 off-the-shelf language identification models on the 2 benchmarks of the Flores and UDHR. In all of the settings, when balancing the F1 and FBR, the GlotLID outperforms all of the models. So we introduced GlotLID, an open source language identification model for 1600 languages. You can find out our model at GitHub and also our demo at Hugging Face.